Section 2.2, the homework problems. I would like to walk through a couple of them in case you're getting stuck or if you just want to check your work. Here we go. So it's all about vertical motion, like dropping an object from on top or throwing an object upward. And they give us the base position function, which is one that you're going to want to memorize and have easy access to. So problem 93 is silver dollars dropped from the top of a building that is 1,362 feet tall. Determine the position and the velocity functions of the coin. So my position function S of t will be equal to, and I'm following this right here, negative 16, there's the effect of gravity, negative 16 t squared, plus the initial velocity, and I'm reading that from right there, v sub o. V sub o, since this thing is dropped like straight out of our hand, it has an initial velocity of 0. So I'd have 0t as my middle term here, plus, because I see a plus sign, and then my initial position, S of 0. Where does this coin start from? Well, it starts from on top of a building that is 1,362 feet tall. So simplifying my position statement, I would have S of t equals negative 16t squared plus 1,362. So that's what we'll begin with. The next thing it asks for is the velocity function. The velocity function is a first derivative of a position. So if we take our position function and do a derivative, that's going to take us to velocity. So I could make that statement that those two are equivalent, and those are equivalent to taking the derivative of this. So the 2 comes down and becomes a multiplier. We're doing the power rule for derivatives. That give us, I'm sorry, that's not what that gives us. It's going to give us 32, isn't it? So back to the pen here. We're going to have negative 32t plus the derivative of 1,362 would be 0. So I'd have plus 0, which I don't really need to write. So we'll take that off. So that's part A. Not so bad. Part B, determine the average velocity. Average velocity is basically the secant line connecting the points x sub 1 equal to 1 and x sub 2 where the point is at 2 something. So when I think of an average velocity is really the normal slope. So I'm going to take y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And for that, then I'm going to need 2 points. And one of the points has an x position starting at 2, and the other point has its x position starting at 2. How do I get the y values? Well, the y values are going to come off our position function, this guy right here. That tells us the height at any particular time. So negative 16 times 1 plus 1,362. So if I take off 16 from this, we're going to be down to 1,346. 1,346 would be its position. After 2 seconds, I would have like y sub 2 or s sub 2. And let's cancel on this. Y sub 2, I'd have negative 16 times 2, and of course that's going to be a negative 32 plus 1,362. So if I take off 32 from this one, I'm at 1,330. So there's my next position. And I'm going to erase my work right here. And next thing, it asks, I still haven't done the average velocity. All I got was my 2 points. So let's go in and do the average velocity. The average velocity is equal to y sub 2 minus y sub 1, 1,330 minus 1,346 over 2 minus 1. And doing the math on that, you can see we have a negative 16 on top over a 1. So average velocity was negative 16. And were we in meters? Nope, we were in feet per second would be our label. Find the instantaneous velocities. So we're on part C here, instantaneous velocities. Well, we found our velocity function earlier on part A, so we can utilize that now with part C. The instantaneous velocity is the first derivative off of the position function. So we're going to take negative 32 and multiply it by the amount of time that has elapsed. So velocity at 1, this endpoint, would be negative 32 times 1 second gives us a velocity of negative 32 feet per second. And the next one would be velocity at 2 seconds. That'd be negative 32 times 2 makes negative 64 feet per second. Not surprising that this is negative because it's a downward motion, and downward motions have a negative velocity. Part D, find the time required for the coin to reach the ground. The time required for the coin to reach the ground would be when the coin has a height of what? Well, when it hits the ground, it would be at a height of 0. So we will use that knowledge. Our position function would be equal to 0 when it strikes the ground, when it's at ground height. Okay, now that's going to allow us to say 0 is equal to the position function, negative 16t squared plus 1362. And that's going to give us some time elements here, which is perfect. So I'm going to factor out a negative 16. And if I pull 16 from 1362, doing a quick division here, I don't quite get it. You know what might be easier? Because it doesn't go in there perfectly. Let me back up. Since that didn't work so well, let's add 16t over. 16t squared, I'm sorry, comes over, equals 1362. Divide by 16, and you're going to see here how this isn't a perfect integer. We're going to get t squared equals that 1362, which is around 85 and an eighth. But nevertheless, it's still just 1362 divided by 16. And now let's take the square root of both sides. Since time is going to be expressed as a positive, I can just keep with the positive root. And if I take the square root of that value, I should get my answer. And I'm coming in with a time element around 9.2263. And I'm going to go 4 decimal places because AP requires 3. So I'm going to go 4 decimals on this. And then it wanted to know how much time. Okay, that's my time. So that's going to be in seconds. That is the answer to part C. Part B, I'm sorry, that's the answer to part D. Part E will be what's the velocity at that particular time of impact. So velocity at that particular time will be just putting our function, part E, take our function for velocity and calculate when time is that. So our velocity function was right here. Velocity with respect to time is negative 32 times t. So minus 32 times our time, 9.2263, but use the stored value that you have still in your calculator, and you will have the most accurate answer you could have. So I'm just going to take my answer and multiply it by negative 32, and that's going to give me a velocity at time 9.2263, equivalent to negative 295.2423. And that answer would be in feet per second. And that's how fast it would have been going when it struck the ground. The negative indicates it was a downward movement.